All right, so ready for question number 3. What is the Pearson correlation coefficient for this data? Is the relationship between sunlight and growth significant at a significance level of 4%? Explain your answer. So pause the video, see if you can put together what the Pearson correlation coefficient is, and then think about this question. Is it significant? And how we would answer that. All right, so you can do this in one of two ways. We've already observed that our slope is positive, so we know we're dealing with a positive correlation. So we don't have to adjust the sign of our multiple r here. This essentially is our correlation coefficient. However, if you don't want to mess with that, you can always just use the Pearson command to compute your correlation coefficient directly from the data. So we could just use Pearson, B3 to B33, A3 to A33, and there we have our Pearson correlation coefficient. Now, it's somewhat close to 1, not super close, it's not like a 0.9, but this could be maybe a medium strength correlation. But strength does not necessarily correspond to significance, so we do have to check, is this thing going to be significant at the population level? And remember, to check this, we need to take a look at the p-value for the hypothesis test for this slope term, okay? When this p-value is below our significance level, and I can change this to a number, so it's something we're a little bit more, so it's something we're a little bit more used to working with. All right, when this p-value is below our significance level, we have a significant correlation. In other words, we're rejecting the null hypothesis that our correlation at the population level is equal to 0. All right, so in this case, our significance level is equal to 4%. And, sorry, our p-value is certainly under 4%. So p is less than alpha. All right, so this means we reject H0, which is claiming that our correlation coefficient is equal to 0. It's also claiming our slope is 0, but we're talking about the correlation for right now. Okay, so this means our correlation at the population level is significant. It's significantly different than 0. So let's package this together in a nice conclusion here. All right, our p-value for the significance of the correlation is 0.0000, I forget what this was, 144, let's call it. Which is less than our significance of 0.04. Okay, so this means we have a significant correlation between the sunlight exposure and the average growth per week. Now in our final question, and then I'm gonna plot this as well just for good measure. In our final question, we ask what percentage of the variation in these average growth rates can be attributed to the linear relationship to sunlight exposure. All right, so whenever you see this percentage of variation attributed or explained by a linear relationship, right, hopefully you're thinking this is my r² value. We can grab this from our growth regression worksheet. So start your cell reference, pop in, grab the r² value. Remember, this is also equal to your Pearson correlation coefficient squared. So that's another way that you could get it. And now if we interpret this as a percentage, that's the percent of variation explained. So we would say we have 48.3% of the variation in growth rates can be explained by the relationship, the linear relationship to sunlight exposure. Okay. All right. So the last thing I want to do here very quickly is just review, right? It's always good to visualize your data. You can really glean a lot more by looking at your data with the appropriate plot than sometimes plowing through all of these different numerical things. So I always like to add a scatter plot, add a trend line, make sure I put my equation and our squared values on the trend line. Remember, you can also, if you're selecting the trend line, you can change the way it looks with the little paint bucket. I usually like to make mine a different color. I like a solid line, sometimes a little heavier line. You could call this maybe growth versus sunlight exposure. And there we have it. All right. All right, so this is our last example dealing with the linear regression outputs, which, remember, we primarily use for the more inferential side of a regression analysis. Aside from these diagnostic plots, which are important, which tell you, is the regression analysis, quote unquote, trustable, we also have these inferential statistics, confidence interval estimates for our slope term, for our intercept term. We have p-values that are testing things like, is the correlation significant? Is our slope non-zero? Is our intercept non-zero? These are the things that Excel's really saving us a lot of time for doing in the background. And it allows us to answer new questions. And we've gone over a bunch of examples of what those questions might be. So combining this with what we already have kind of practiced with correlation and linear regression, we're now in a nice position to be able to do some good research with regression analysis. Answer some good research questions.